When we talk about digital twins, one thing that comes to mind is 3D representation, 3D visualization. And it's something that's not easy to do. The 3D world and designer world is kind of different to the digital world of data. The 3D Studio for digital twins is solving that problem and make it super easy to correlate a 3D visualization with Azure Digital Twins. And I have Riley today on the IoT Show to tell us everything you need to know about this. Hi everyone, this is the IoT Show. I'm Olivier, your host, and today we'll talk about 3D visualizations of digital twins, and for that we have Riley here on the show today. Hey Riley, how are you?
Hey, good. How's it going? Thanks for having me.
I'm great. So it's not the first time you came. You always have very interesting and fun demos to show us. So before we jump into that, because not everyone has seen your previous episode with us here on the IoT Show, who are you? What are you doing at Microsoft?
Yes, of course. My name is Riley. I'm a PM with Azure Digital Twins, leading up the user experiences for ADT. From the cloud developer-focused ADT Explorer, which is where I've done my previous work with your show, and the new 3D Scene Studio, targeting more of a kind of business-type user.
3D Scene Studios for digital twins. So how does that connect? What's the relationship between 3D scenes and digital twins?
Absolutely. So digital twins itself is a digital representation of your business world, right? It's kind of the underlying data to all of that. But I've been with the team for a little while here, and one of the first things that customers actually ask is, cool, I have this really exciting insights and data, but how do I actually visualize this? How do I create these or show these insights to my end users, the operators, the analysts that want to consume this data and use it for business decision making? So for a while, the team kind of worked towards empowering customers to create their own worlds, their own client applications. But it's become pretty clear that 3D visualization is actually just the most intuitive way to understand your digital twin and the related data. And it's absolutely not that easy to combine 3D world in general with digital twins today. So especially for the role that actually ends up knowing the OT, IT knowledge for those kind of visualizations, right?
Yeah, we're indeed at an interesting intersection of technologies. And so I'd like actually for you to tell me about some examples of use cases, some scenarios where 3D is really needed. Because sometimes it can feel a bit like science fiction or overkill to have an actual 3D rendering with IoT data on top of that. Do you have a couple of examples where that can be useful and productive rather than just here for the fun of it?
Absolutely, and also to give it a sense of kind of what we see the whole bucket of 3D scenes as is, it really boils down to a 3D view of a business environment, right? So intelligent data visualizations and insights based on the underlying twins data that can be very flexible and can kind of represent a lot of different scenarios and use cases for customers. One of our partners, Cosmotech, is playing out a wind farm turbine simulation in order to optimize maintenance on those wind turbines and to be able to depict these outcomes to their end customers. Are kind of leveraging 3D scenes in that capacity. Another partner talks about live monitoring of building occupancy and environment data in the scenario of evacuations and emergencies, where being able to see the entire picture is really important in those kind of critical situations. And finally, a really cool one that we've kind of incubated internally is working around the International Space Station, where some of my teammates kind of spun up this 3D scene of real ISS data feeding into this 3D scene, kind of depicting how a command control center might be monitoring the ISS.
Interesting. We had Alex recently on the IoT Show showing that exact application you just brought up here using a HoloLens. Because once you have a 3D model where you have data attached to it, you can actually use different types of application or client applications to visualize the 3D model. But so 3D, for people who are not graphic designers, that can be really hard, right? Or totally like, whoa, this kind of like black box thing that is pretty, or play games with that or whatever, but I don't really understand how that works. And data and digital twins might be something very foreign to 3D designers, to graphical designers. How do we reconcile these two in the tool you're building and for our customers?
Absolutely. So what really is important here is we kind of see the user of this application more the kind of industry expert, the actual employees of our customers that understand the inner workings of the assets that they're managing or they're trying to understand. So it's not even truly trying to empower the kind of more graphic design side of the world, but more empower these kind of SMEs in their own fields to kind of quickly get up and going with this 3D technology, especially by abstracting away a lot of the more complex needs of 3D modeling, and connecting the digital twin by, again, simplifying what a digital twin is and reducing the amount of kind of cognitive background knowledge they need on what their digital twin looks like.
Nice. I think it's enough teasing. We need to look at this tool and how it works.
Absolutely. And I think one great way to kind of introduce the idea of these 3D scenes is to actually look at this ISS demo we have here. Just to kind of poke around at what the actual consumption experience looks like, because as you'll notice, there is both the building side of 3D scenes and there's the consuming. So as you can kind of see here, we have this ISS scene where there's a couple kind of key things to point out. First of all, I can see live insights of the ISS, both through the color overlays of the on these solar panels, as well as the alerts that are showing situations that are unfolding in real time. I can also see the full list of the assets of interest and actually poke around between these different assets to understand and diagnose a little bit deeper as to what's going on with each of these assets. And in order to diagnose, there are even these widgets that kind of display some of this data in a more understandable way to kind of learn more and dig in deeper. So that's kind of what a good 3D scene is. And I do want to call out that 3D scenes are not the only way to visualize data, but it's just the most natural way that we've found from the team and with our customers, especially for a broader audience with less technical backgrounds.
Yeah, no, definitely. And what you'll certainly talk to us a bit more about is how it's been built. How did you land here? Because here we're seeing something that seems complicated, right? But how hard is it to compose such a 3D visualization and compose with the data coming from digital twins? So in that IT show with Alex, he was telling us about the fact that you have a real-time feed coming from the ISS that he was able to create a model in ADT for. So he has the data in there in ADT in the right format because he created the model and now he's able to inject the data using IoT Hub. So once you have that, so how do you reconcile with a 3D model, and what kind of files or content do you need to create that 3D rendering?
It's really easy too. Once you have your 3D model, and we'll even just walk through, I think that's one of the best ways to be able to see what it takes is to just do it by doing it, because it's really super simple, and all you really end up needing is your digital twins instance and the 3D model that you're trying to create a scene around. So here we're in the builder side of the 3D Scene Studio, where we're first of all going to link the digital twins instance and the Azure storage container that we're going to use to store the 3D content as well as the kind of configuration data for the scene. So here I've already placed in the ADT instance and the storage container URL. So now we can get to actually creating our first scene. First thing to note here is we're going to create one scene today, but you can create many that relate to your single digital twins instance, because there might be many representations of the same data for different roles, especially. The role or the kind of scenario that we're focusing around today is a distribution center. I already have uploaded the 3D file to my storage container, so we can just go ahead and leverage that immediately.
And that's a standard, right? The format you're using for this 3D file is something that's used today in the industry.
Exactly. We take GLTF and GLB, both pretty common file formats, and at the very least, relatively easy to convert any existing CAD or point cloud models into this format to kind of pop into your scene.
Okay.
So now that we've kind of created that scene, let's hop right into it. Immediately, you can see the distribution center rendered here, and what you'll kind of notice is there's a bit of an animation of these robotic arms here. What our Contoso world is most interested in here is triaging boxes. These automated robots will basically pick up boxes and triage them based on the data they have on those boxes. And there's video cameras in the room, which are basically monitoring the arms are picking up them correctly, to alert when they have not picked up a box correctly, and to also notify the operator if the robotic arms need maintenance for any reason.
Okay.
So we'll kind of go through building that whole scenario.
That works.
So the first thing that you need to do, kind of the building blocks of 3D scenes, is create elements. So for each of these robotic arms, what we want to do is create that inherent mapping with the digital twin to those 3D meshes. And once you kind of have created all of those mappings, then you can start to build the actual business logic on top of the 3D environment.
Yeah. So basically pair a graphical element with a property in a tween, with a tween. What do you pair it with?
Exactly. So you're mapping it directly to a single twin in the background. Now, there's also the ability to map to multiple twins if you need to leverage data more than just that core twin. But at default, one twin is all it takes.
Okay.
Yeah. So these arms that we have here are pretty well segmented, so it's not too hard to click around, create those mappings. So we'll just go ahead and create 4 of these just so that we can be able to see our business logic well.
Okay.
And one more here. You can see it's pretty easy to actually start the mapping process, which is super nice.
And fun.
Yeah, it's a ton of fun, right? Just kind of pop around this experience. And,
yeah. So
and
now when my kids are going to play, Minecraft, and we'll tell them stop playing, they will look at me working in that. It was like, what are you doing, Dad? Playing Minecraft?
Yeah, you're playing the same games as me.
Exactly.
Yeah, exactly. So now we have each of the 4 elements. Now we kind of get to the meat of the experience. We can start to define behaviors. Behaviors are truly the actual logic around the visual cues that you have in your scene. And today we only really need one.
Okay.
We're going to focus around this idea of arm pickup, or rather, box triage success, because that's kind of the main goal of what Contoso is worried about here. This behavior is going to be targeting each of the elements that we've just created. So we'll go ahead and apply all those arms in there right now. There's 3 kind of big levers that you can pull in a behavior to indicate different scenarios and visualizations on the scene side. The first is a status. Status is effectively a color overlay on the elements themselves to indicate a certain health of those elements. So in our case, we're mostly interested in understanding the health as it relates to the number of failed pickups, because number of failed pickups is directly correlated to whether or not the asset or the arm is likely going to need maintenance. So as far as I know here, under 3 failed pickups, 1 to 3 is totally fine. But if there are more than 3 failed pickups in the past hour, then that means the operator, the end user of the scene, needs to kind of trigger the maintenance process to diagnose and solve for that arm. The next lever we have here is alerts. So the alert scenario that we're most interested in, and alerts, to be fair, are the kind of badging and notification expressions that tell the end user, the operator, that the element requires attention on a specific kind of multivariable situation. So we'll go with a pretty simple one today. We'll actually, and you'll see me here using IntelliSense to leverage the underlying data in the maps digital twins for each of the elements to actually build these expressions in live. It's nice. Very easy to do, and then we can pull out these Boolean expressions super easily. So for this alert, all we really care about is when this pickup failed alert Boolean goes true, meaning that the arm has failed to pick up a box. We want to surface that alert, and that alert really just looks like a little alarm, red alarm bell, and we'll pop in the expression for what we want to show. Here we're kind of using the box ID from the underlying digital twin and saying that box ID's pickup has failed. Please manually triage that box, get it to the right location. And also you can kind of start to see the preview of these visualizations popping up on the popover preview here.
Yeah.
which helps, especially as we get to our last one, the widgets. Widgets are especially shown in the preview. They're kind of the drill down diagnostic information for each of these elements. And today there's two things that are most interesting to us. You have a couple different widgets at your disposal, but for this first one, we're going to create a gauge that speaks to the hydraulic pressure of the arms, basically because this is the most indicative variable to whether or not the arm is likely going to need maintenance soon. So we're going to create this hydraulic pressure. We'll assign a unit of measure for that. And we'll use this hydraulic pressure property that is kind of existing on the digital twins themselves.
Okay.
I'm no expert on hydraulic pressure, but as far as I know, the ranges of the good ranges here are 20 to 30.
Okay.
But once you get above 30 or below 20, then you're in a danger zone.
Okay.
So we'll show that in our gauge here, kind of showing that there's that good happy zone in the middle that we want to be in. And we'll go ahead and create that widget. The last one is when an operator kind of understands, this is something that I need to be doing, probably triggering this maintenance process, I probably need to link in and see the past records of maintenance to understand what likely the issue is probably going to be and how to go about that. And to do that, we'll add a little smart widget that really just links into the maintenance records for the given element. What's really cool here, though, is we're going to leverage a digital twin property, the DTID, of the arm to link specifically to the right dashboard that has the exact context of the arm and nothing else for that end user operator, which is really nice.
Nice. And the beauty of that is that if you're changing the backend to have a different dashboard or an updated version, your 3D model actually or rendering will still point to the right, to the good one, to the new one, right? Automatically. You don't have to change your 3D scene to apply this change that's been happening in the backend.
Exactly. Once you kind of make that contract with the interacting applications, then yeah, it's a lot easier to kind of keep that maintenance.
Nice.
Up. Cool. So we'll go ahead and create that widget, and now we are done with this behavior. One other thing to mention here is you can create scene layers, which are effectively just the kind of buckets of behaviors, so that you can kind of curate how you want to group your behaviors for the end user. For example, let's say some roles are only interested in the power consumption or the sanitation side of the scene. You can kind of bucketize those behaviors. Today, we're just doing one, so we won't need that whole layers functionality.
Got it.
So we're going to create that, and now we're good to go. Let's validate that we actually have created a scene here, and that these behaviors are working. And you'll see that there's actually live data being pumped into this. So all of the the colors changing and the alarms are due to real data changes, indicating that some of these might be requiring maintenance, or some of them have failed to pick up a box.
Okay.
And that's pretty much it.
Nice, nice. And you developed that. So the interesting thing here is people didn't realize that. You're in a web browser, right?
Yeah, 100%.
So everything here is the tool itself. How do we call that? The 3D Studio for digital twins?
Yeah, it's built on Babylon 5.0, which really allows us to do these super lightweight 3D renderings in any web interface, which is very useful, especially for customers who are today using these more heavier desktop 3D applications that might not be as accessible to a lot of their end users.
Nice. Little shout out to the Babylon team. I'll actually say hi to my friend David, who was leading that team. I think they're doing a fantastic job, because I bet that creating that tool using Babylon has been a breeze for you guys.
A breeze, totally.
Awesome, Riley. So awesome tool. I invite everyone to go check out the link below here to go check out the 3D Studio tool for digital twins. Riley, thank a lot for a nice demo. We'll hear more about you and these tools for digital twins visualization and so on. And well, I look forward to see some actual customers using that in production.
Very exciting. Thank you so much, Olivia.
Thanks. See you all, and well, see you soon on the IT Show. Bye.